All right, moving on to the 3.7 notes. Here we're going to be solving these compound inequalities. We're going to start off by solving the compound and inequalities. Again, those compound ands are set up this way, where we have the two inequalities in one. I call this a three-part compound inequality. So part A says 2 is less than x plus 5 is less than 9. All right, so again, the goal here with any inequality you're trying to solve is to isolate the variable. So we want to get x by itself. So we need to undo operations. So to get the x by itself, we need to do the opposite of adding 5, which is subtracting 5. But you notice that we subtracted 5 in two other places. All right, so we have to subtract 5 on the left half of the double inequality and on the right half. Again, we know we're done when x is by itself. So there's our answer. Negative 3 is less than x is less than 4. Moving on to example B. Again, we want to get y by itself, so we need to undo operations. We're going to subtract 4 from all three parts and divide everything by 2. All right, so we got y by itself in the middle, and we have 3 is less than or equal to y is less than or equal to 10. All right, moving on to part C. Again, we're trying to get x by itself, so we need to start undoing some operations in this three-part inequality. So I'm going to add 3 to all three parts. So I got negative 2 is less than or equal to negative x is less than or equal to 5. All right, again, I'm going to stick that 1 in there between the negative and the x, so now I see negative 1 times x. So that will help me better figure out what I need to do to get x by itself. And because that negative 1 is being multiplied to x, to get rid of it, we need to divide by negative 1. So I'm going to divide all three parts by negative 1. All right, now because I divided by a negative to get x by itself, I want you to notice that the inequality symbol flipped. We originally had less than or equal to symbols around the x, but now I flipped it to greater than or equal to symbols. Again, because we divided by a negative, the inequalities in the original problem had to flip. Now, we need to adjust our final answer here, because we talked about how when we write these inequalities, right, we always want our smaller numbers to be on the left and our larger numbers to be on the right. Negative 5 is smaller than 2. So we need to flip-flop those numbers. All right, so I'm going to change the places of the 2 and the negative 5. So now the negative 5 is on the left, the positive 2 is on the right. But if you recall, when it comes to the inequality symbols, that if we are going to flip-flop and switch places with the numbers in an inequality, we need to flip that inequality. So where I originally had a less than or equal to symbol, I flipped it to a greater than symbol because I divided by a negative. I've got to flip it one more time because I switched places. Okay. So in this one problem, we had to flip that inequality twice. Once because we divided by a negative, a second time because I switched the numbers around. This is our final answer. All right, let's move on to example D. I'm going to subtract 3 from all three parts. To get x by itself, we need to divide all three parts by negative 2. And because we divided by a negative, that inequality symbol had to flip for both. And because the -8 is on the right and the +1 is on the left, we need to switch places. And because we switched to places in the inequality, we had to flip the inequality symbols. All right, so now let's go ahead and solve the compound OR inequalities. So again, we talked about the compound OR. They are two separate inequalities in one problem. So the way you would solve these is that you would solve each of those two inequalities separately. All right, so for the inequality on the left of the OR, we're going to undo the operations to get x by itself, and we get x is less than 3. And for the one on the right, we're going to undo the operations, get x by itself, we get x is greater than 6. Okay, so again, we're going to solve each half of the compound OR separately. And when we get down to our final answer, just need to make sure we put the word OR in there. And together, our final answer is x is less than 3 or x is greater than 6. All right, moving on to part B. Undoing the operations, we get c is less than or equal to -1 for the first half of that compound OR. And for the one on the right, we undo the operations, we get c is greater than 4. Okay, so again, we're solving these separately for the compound OR, each of them doing their own separate steps. And we finally get to the bottom here, where we have our two totally separate inequalities. We're going to bring them together with the word OR, and that's going to be our final answer. All right, let's see what you can do here with example number 1 for the U try. Again, we're back to a compound and inequality, three-part inequality, where the variable is in the middle. All right, so let's see what you get here for example number 1. All right, so undoing the operation of adding 5, we're going to subtract 5 from all three parts in this compound and that's all we need to do to get x by itself. So our solution is a three-part solution, 1 less than x less than or equal to 6. All right, now we need to write our answer using interval notation and to graph it on a number line. So let's start with graphing on the number line. Again, because we have a or equal to with the 6, we're going to put a closed circle on 6. And because we do not have an or equal to symbol next to the 1, we're going to put an open circle. And as we talked about yesterday, for the graph, the solution for this three-part and inequality, with x being in the middle, we are going to shade in the middle. Okay, these are where all the values are that x can be. X has to be somewhere in between 1 and 6. How about that interval notation? Open circle on 1 means parentheses by the 1. This graph ends at 6 on the right, and because it's a closed circle, we do the squared off bracket. All right, let's see what you do here with example number 2. Again, a three-part and inequality. All right, to get m by itself, we have to divide all three parts by -4. Again, because we divided by negative, those inequality symbols, those less than symbols, had to flip into greater than symbols. So initially, this is what our answer could look like. 1/4 is greater than or equal to m, is greater than or equal to -4. Again, we need to fix that. We need to switch places with the 1/4 and the -4. And because we switch places with those numbers in the inequality, that inequality above needs to flip again. So there's our solution for this 3-part and inequality. Let's go ahead and graph that. So we got closed circles on -4 and +1/4. +1/4 is somewhere between 0 and 1. And we're going to shade in between. That's where all the values at m are, between -4 and +1/4. For the interval notation answer, again, because we have closed circle on both the -4 and 1/4, we're going to use the squared off brackets. All right, let's move on to example number 3 with those compound ors. See what you got. All right, again, with the compound or, you got the two totally separate inequalities. So you solve for the one on the left. You get r is less than 2. And again, solving for the one on the right. Again, because we had to divide by a negative to get r by itself, we also had to flip that inequality. So we get r is greater than or equal to 7. Let's get the or in the middle, and there's our inequality answer. All right, so now to do the graph. Can you recall from yesterday's lesson, what does that graph look like for the compound or? Again, for the left half of that compound or answer, r is less than 2. So open circle on 2, and we're shading to the left. For the right half, we got r is greater than or equal to 7. So close circle on 7, and because r is greater than 7, we need to shade to the right. Again, the graph for the compound or is this split graph. Now on to the interval notation. Again, this is the interval notation for the left half of that graph. Parentheses, -infinity, comma, 2 parentheses. And this is the interval notation for the one on the right. Close circle on 7 means bracket on 7 for our interval notation, comma, infinity, parentheses. Again, we're going to join these two solutions with the U symbol, the union symbol. All right, skip over to number 5 for one more try at the compound or. Let's see what you get. All right, so when you solve the one on the left, we got w is less than -17. And the one on the right, w is greater than 5. All right, we got to put -17 here on our number line so that we can graph. Open circle -17, shade to the left. Find 5, open circle, shade to the right. Split graph for the compound or. All right, and finally for interval notation. -infinity, comma, -17, union 5, comma, infinity. All right, that's it for today. Let's move on to the 3.7 homework.